In this video, we will demonstrate the use of the FLOWIDER Shiny app. In the FLOWIDER app, there are 4 main tabs. In the first tab, that is the Map tab, we can see the location pins for the 107 gauging stations belonging to 24 rivers and 6 Indian states in the Gangetic Plains. Stations can be selected according to threatened species of interest or according to rivers of interest. In the Graph tab, we can view the flood time series for the entire dataset or for a specific date range. In the Metadata tab, we provide several useful information pertaining to the stations such as danger level, zero level, dams and barrages that are located upstream and downstream of the station, protected areas or PAs relevant to the station, and links to other satellite-based datasets on river water level or discharge such as Thea Hydroweb, the Hiti, Riverwatch datasets. In the About tab, we provide a detailed description of the app along with instructions on use, terms of use, restrictions, data sources, and importantly, the source code for the app. Let us click on Clear Selection and let us look specifically at 2 use cases of the app, one based on species and another based on river. Let us say, for example, that we are interested in understanding the effect of rise or fall in water level on the nesting success of an endangered bird species, the Indian skimmer. We will choose the Indian skimmer option in the Species tab, upon which only the stations relevant to the distribution of the bird in the Gangetic Plains gets highlighted. Let us say that we are interested in the station Dholpur on the river Chambal. Given that the hatching of the bird in this region occurs in the month of June, let us say that we are interested in seeing the water level in June 2020. This is our water level graph, and on hover we can see the various water level values corresponding to the different dates and can correlate the rise and fall in water level to the nesting success of this bird. Now this graph can also be downloaded as a PNG file using this option. Moving on to the metadata, we can see all the information relevant to the chosen station Dholpur in this tab. Danger level, zero level, and other such useful information, including links to the other satellite-based datasets. Moving to our second example, let us say we are interested in seeing the influence of water level at one station on another station. Let us take the example of the Bihar floods of August 2016 as our case study. One of the potential hypotheses regarding the cause of this flood was the sudden release of water from the Indrapuri Dam on the Son River located in this area. To illustrate this influence, let us choose one upstream station and one downstream station. We choose the rivers here, the upstream station being Indrapuri and the downstream station being Farakka, for example. Given that we are specifically interested in investigating the flood behavior of August 2016, let us compare it with the flooding behavior of the year before and the year after. In this graph, we can see the flood water level data for both the stations simultaneously. And we can see very clearly that in August 2016, there was a sudden jump in the water level at Indrapuri and a corresponding rise in water level at Farakka as well. On zooming in, using the compare data on hover option, we can see the specific dates on which this rise in water level happened. For example, on 20th August 2016, the water level at Indrapuri nearly touched its danger level and had exceeded the danger level at Farakka. Such interesting investigations can be done using the app, wherein we look at the influence of water level at one station on the other. Now going further to the metadata tab, we can see useful information regarding both the stations at the same time, as has been demonstrated in the previous use case. Now this concludes the demonstration for the app. We hope that users will find this useful and will be able to experiment with the various functionalities of the app.